This video is on systems of nonlinear equations. We are going to solve these by graphing. We need to put them into the y equals format so we can graph them. We need to make sure that all of our graphs have the x and the y labeled on our axes. So I'm going to go ahead and label all four of these graphs with an x and a y that I have. First graph I'm going to graph in pink. I need to rewrite this so it is in y equals format. I need to add the 5 to the other side. So this will be rewritten as y equals the absolute value of x plus 2, absolute value, plus 5. So I'm going to graph this. Since this is absolute value, we have a vertex and our slope of 1. Our vertex is at -2, +5. Our slope is 1. So we start from the vertex and go to the right. So we're going to go up 1, right 1. Up 1, right 1. All the way through. Then we're going to mirror these coordinates. So we're still going to go up 1, but we're going to go left 1 instead. Up 1, left 1. Up 1, left 1. And then we're going to connect these. I'm going to use a straight edge to make these accurate. They will keep going up and to the right. And then I'm going to do the same thing on this side with a straight edge. These will keep going up and to the left. The next one is, I'm going to graph in blue. I need to put this, since this is linear, I'm going to put this in slope-intercept form. So I will have y equals, I have the negative x, I'll have to divide it by 2. So it's negative x divided by 2. I'll have to add the 8 and then divide by 2. So it'll become a positive 4. So the y-intercept is 4. And our slope is -1/2. So -1, right 2. Down 1, right 2. Until I can't go any further. Same thing as up 1, left 2. Up 1, left 2. And then I'm going to use a straight edge again to connect these coordinates. To make them as accurate as possible. Roughly. Arrows on them. And I want to find where these two graphs intersect, and they both cross through this coordinate of -2, 5. So that is our solution, -2, 5. This next example, the first one is already in y equals format, but this is an exponential, so we will probably want to get some coordinates from our calculator. So I'm going to turn my calculator on. I'm going to go to my y equals. I'm going to type in 2 raised to the parentheses x minus 3 close parentheses. Then I'm going to go to my table and I'm going to find some ones that I can kind of graph. And I can look at the graph to see what it's going to look like. It's going to go up. It will never actually hit that 0, so I do want it to have an asymptote. So I'll go to my table, get some coordinates. So the first decent coordinate I could graph is probably 2 and then a half. So 2 and a half right there. I could probably graph that 1 and a quarter right there. And then that 0 is going to get even closer to the axis, but it's not actually going to touch. So then I'm going to get some other ones. So 3, 1, 3, 1. 4, 2, 5, 4, 6, 8, and then 7, 16. So I can't graph that one. But it does, as I go to those x values of negative, it's not actually going to hit that 0. So I actually got to make it go really close to this axis. So it's an asymptote. It's going to keep going. But then it will curve this way. It'll keep going up. So now the blue, I need to put this into the correct format. So I'm going to have y equals. I'm going to have to subtract the x, but I will have to take the square root. I will have to take the square root. When I take the square root, I have to put a plus or minus on the square root symbol. And I would have subtracted that x already. So x, negative x, and then plus 8. So I need to graph this, and I can also use this in my calculator. I'm going to have a positive aspect and a negative aspect. So I'm going to go to the positive. I'm going to put in the square root of just negative x plus 8. I want to graph this. So this is a square root, but it's going towards the left because it's reflected over the y-axis because the x is negative. Now, the negative aspect of this here will mean it's reflected over the x-axis, so it's actually going to be pointing down. So really, it's just a mirror image of this one. If I go to y equals and I go into my second one, I'll put negative square root of negative x plus 8, and I'll graph that one. So it's just that mirrored image. So I only really need one of these graphs, and I'll just mirror it. So I'll go to y equals, I'll just clear out the second one, and I'll just get the coordinates for these. So I need to find my first x value should be at that that positive 8 because that's our vertex. So positive 8, and then after that there should be an arrow. So it should be 8, 0, 8, 0, 7, 1. And the next good one is 4, 2. Then we have negative 1, 3. Let's see if there are any other good ones. We have negative 8, 4. So we can graph negative 8, positive 4. So negative 8, positive 4. So now we need to mirror that across the x-axis. So 1 away, 1 away. 2, 2 away. 1, 2, 3, 1, 2, 3, 3 away. 1, 2, 3, 4, 1, 2, 3, 4 away. Because this is the positive part of the plus or minus, and this is the minus part of the square root. We can connect these. So then these do intersect just once right here. They both share this coordinate. It will not intersect anywhere over here because this will keep going up and this one will keep going down. This pink one will not cross that x-axis. So our solution is at 4, 2. On this next one, we have two lines and they're already in slope-intercept form, so we can go ahead and graph them. First one's in pink. Positive 2, and then slope is 1/3. So up 1, right 3, up 1, right 3, 1, right 3. Down 1, left 3, down 1, left 3, down 1, left 3. Straight edge, going to connect these. The blue one starts out at negative 2, and our slope is the same, so they should be parallel. Up 1, right 3, up 1, right 3, up 1, right 3, down 1, left 3, down 1, left 3, down 1, left 3. So just from the equations themselves, we could already have determined that this would be no solution. These will not cross because these lines are parallel. These lines are parallel because they have the exact same slope, but with different y-intercepts. So this is a no solution. They never cross. On this last one, I got to get this into y equals. So I need to divide this entire thing by 2. So I will have y equals, I'm going to put it as parentheses x plus 1, parentheses, x minus 5, close parentheses, all over 2. So I'm going to go into my calculator and graph this. So I'll go to y equals and clear it out. I'm going to type in parentheses x plus 1, parentheses, x minus 5, parentheses, and then divide that by 2. I want to go ahead and graph it just to see what it's going to look like. It's a parabola. So I want to get some good coordinates. So table. Alright, so negatives are too big. Can't use that, but I can use negative 5. Cannot use negative 520. That's too large. So the next good one is negative 3, positive 8. So negative 3, positive 8. then -1, 0, because that would have been an x-intercept. 1, -4. Looks like that might be our vertex. Then we have, it's not actually our vertex. Our vertex is lower than that. Our vertex is at 2 and then -4.5. So I'm going to go ahead and put that in there. We know that this is our vertex because these y values start repeating after the vertex. See how this would then repeat? That middle term is your vertex. So the next good coordinate is 3, -4. So we're just going to mirror them now. So then it should be 5, 0, 7, 8, and that should be it. So try and put these as best as possible. Curving through them. Arrows. And then my blue one. My blue one is already in y equals, so I'm just going to graph it, clear it out. So x squared minus 4x minus 1. Graph it so we can kind of find where our vertex might be, kind of over in here again. So our table, see if we can graph any of the negative x values. We can graph -2, 11 is a little off the graph, but we can try and graph it. -2, positive 11, somewhere around here. -1, positive 4. 0, -1. 0, -1 here. 1, -4. 2, -5. This one is going to be your vertex because, again, the -4s are repeating after it. So the next one is 3, -4. 4, -1. And it's just going to mirror again. So 5, 4. And then 6, 11. So again, a little off the graph. 6, 11. I'm going to connect these. So these graphs actually cross twice. They share 2 coordinates. So this coordinate right here and this coordinate right there. Those are our 2 solutions. So when we write our answers, we have to write them out both. We have that 1, -4 and 3, -4. You could write it as 3, -4 and 1, -4. It doesn't matter. But these are both of your solutions. Not just one. So nonlinear equations could actually cross multiple times. This one crossed twice, but some might still only cross once. It really depends on what type of equations you have. You can also do all of this in your calculator. I can go into here and go to my y equals, type in my original, which is my first one is x plus 1, parentheses, parentheses, x minus 5, close parentheses, divided by 2. And then my second equation is x squared minus 4x minus 1. I can press graph, and I can graph both of these, so I should be able to see my pink and then my blue. And I can go find I can calculate the intersection. So second trace, I'm going to calculate the intersection, which is number 5. I want to move my cursor to an intersection, so kind of close to that. Enter 3 times. 1, 2, 3. 1, -4. But we have another one, so I'll do second trace, intersect again. But I'm going to go over to this intersection. Press enter 3 times. 1, 2, 3. Same thing, so 3, -4. So I'm able to find them using my calculator by finding the intersection using second trace.